Last time we ended saying what a one sample test is, which is essentially what we were doing all along. We have a one sample test if it only comes from one sample, and we are just comparing we're just comparing its validity with respect to the population itself, right? And so how about if we wanted to compare two different samples, like comparing salaries of men and women? And so remember that if we wanted to compare two things, all we wanted to really do is to find out whether one of them belongs to one distribution. So let's say that we got a sample from the men, and it has its own sampling distribution, right? And then we got a sample from the female. So let's have that pink sampling distribution, and each one of it would have its own mean, right? Have its own mean, and also that's for the female, has its own mean. All right. Now, if you wanted to know how different these two distributions are, what you can do is you test. You just choose which one to put into. Like, if I choose the xi of the females, let's call it f. I just need to test whether this xi of the female belongs on that distribution. So how am I going to put the xif of the females to that distribution? Well, if I wanted to do that, well, I just need to get its z-score or t-score, right? Let's say that the sample size that I obtained for both is large enough. Let's say it's more than 30, and then what I need to get is the z-score. And if it's a z-score, the formula is just if this is the thing that I wanted to test, and that's xif minus the mean of the distribution I wanted to know if xif belongs to. So the mean of the distribution, this is the mean of the distribution. Let me encircle it. That's the mean of the distribution, and xif is the statistic. So this is my statistic. There you go. All over the standard deviation. The standard deviation of the sampling distribution, and make sure that it is all over the square root of n, the sample size, right? Sample size. Alright, and as we learned last time, you can approximate the standard deviation of the population from the sample standard deviation. Alright, it's quite nice. And what would you get the sample standard deviation? Well, if we're given two different standard deviations for both, then what we can do is expand its dimensions. This can only be used if the sample has the same standard deviation. But what about if the male has a different standard deviation? Let's call that S1, and the female also has a different standard deviation. Let's call that one S2. And hence, if that's the case, then what happens to that is we would have a formula that looks like this. So we will combine S1 and S2. It turns out to be that for you to combine both, it's just as simple as adding them. So we have S1 all over square root of its own n plus S2 over the square root of its own n. Alright, so that's what it is. So if it's different, we need to use this. If they're the same, then you can just use this.